Hello, my name is Luis Acevedo Arreguin. I'm going to be your math instructor for Math 16, Elementary Statistics. So first, I'm going to show you a PowerPoint presentation. So here you're going to see the basics that you're going to be about our class. So the first thing is a little bit about my background. So you can see here that these are the classes I'm teaching at Monterey Peninsula College. I studied applied mathematics and statistics, and I got a PhD from UC Santa Cruz. And when I'm not teaching at MPC, you can find me at the Cwk Public Library, where I run a U.S. citizenship program and also help students to get their DACA. And another activity that I do at the Cwk Public Library is helping students with mathematics from elementary school through university. So if you ever need help, you can find me at the Cwk Public Library. So our class is going to be based mostly on MPC Canvas. So you're going to need to go to www.mpc.edu, and you're going to click on the Lobo Apps link, and then you're going to be able to get into Canvas. So for that, you're going to need your student ID and your password to log in. If you don't have any, you need to contact the MPC library as soon as possible. So this is the web page, the main web page of MPC. So there is a link here, is the Lobo Apps link. So you click here and you're gonna get to enter your credentials. So your usually your email address and the password that you are given, and then you're gonna be able to see all these apps that are for all MPC students. So the one that we're gonna use most of the time is Canvas. So you're gonna click here on this icon, and you're gonna get all the courses that you are taking at MPC. So you're gonna look for Math 16 and the corresponding semester. So once you click there, you're gonna get a page like this one. So, and we can just try to get into the actual page. So let me see. Let's go and check our. This is the page that you're gonna get if you click on Math 16 for this semester. So you're gonna see a graph like this, and then there is the information, the basic information about this course, the description, and also some materials that we're going to use here. And another important part is that you're going to have the grade distribution on the right hand side. So another thing that we're going to find in our web page is our online compiler that is used to get into R, which is going to be the computational tool that we're going to use for this course. I'm going to explain a little bit about that in a minute. So once you get here, let's see, we're gonna now check the rest of the presentation. So we have here, let's see, we're gonna continue with the rest. So let's look up the syllabus for this course, Math 16 Elementary Statistics. So you can see here that we're gonna have, we're gonna use elementary statistics from William Navidi and Barry Monk, and also there are the SLOs here, the student learning outcomes, and then the grading policy. I think this is the most important one for students taking this class. So we're gonna have let's see, we're gonna have a grade distribution in this way. So we're gonna have homework, it's gonna get 20% of your grade, classwork 10%, quizzes 20%, tests 30%, and the final exam 20%. So homework will be assigned every week, and you're gonna need to upload your material electronically through Canvas. So you're gonna click the submit button. You might need to get an app for your iPhone to convert any screenshot into a PDF file. So there are many apps available now, like Cam Scanner or PDF Scanner. And every week try to work on your homework. It's going to be just a few problems to solve. Those problems are going to be very related to the material that we cover in any lecture. So classwork will be assigned also during every lecture. So you need to watch the videos, or you need to attend the lecture if we are in a face-to-face environment. And during the class, I'm going to assign a couple of problems, and you need to work those problems later, and then you're going to submit those problems. Also using the classwork assignment section. So there are going to be also quizzes, and they are going to be graded automatically on Canvas anytime that you take it, the quiz. And those quizzes are going to be about the chapter, so there are going to be one quiz per chapter. It's very important for you to take these quizzes because they are also showing the kind of problems that you're going to have in the test and in the final exam. So if you go through the quizzes and solve those problems very well, you're going to succeed in this course. So pay attention to the quizzes. Another thing is that quizzes, you're going to have 2 attempts to pass the quiz with a good grade. So the first time that you take the quiz, and if you don't get everything correct, just take note of your questions and send me an email, and I'm going to help you. So we're going to have 2 exams, midterms during the course. They're going to be 3% of your grade, and you're going to need to use an app that is known as Proctorio. So to be able to take the test. The test is going to be also graded automatically, so you're going to have feedback once you finish the exam. So this time the test is going to be very similar to a quiz, with the difference that it's only one attempt, and they all is going to be time limited quizzes. On the other hand, you don't have time limitations. The only limitation is the deadline. But for the test, you're going to have a limited time to take the quiz. Also, you need a webcam, you need a laptop, you need a microphone. So there are many things that you need to take a quiz by using the app Proctorio. Students have taken these quizzes through the app successfully in the past, so it's very simple. There's a lot of information on how to take exams by using Proctorio on Canvas. Then the final exam is going to be another repetition in terms of the format. So it's similar to the quizzes, it's similar to the tests. You need Proctorio, and you're going to need to use only one computer. So you're going to be able to run your app, your language R in your computer. And if you need to go to the website where R is, you are going to be allowed to use that website. So, but the only thing is that you need to use only one computer for taking the test and for using your software. So you have the PDF file corresponding to this syllabus uploaded on Canvas, so check later. So about calculators and laptops, we're going to use the R programming language. I'm going to explain about this language a little bit later. It's free, it's very easy to use. We're not going to do computer programming, so we're going to use language R only as a very advanced calculator, a very simple one. So, and again, I'm going to repeat this many times. Everything is going to be on MPC Canvas. So this classroom behavior policy is when we have the face-to-face classes. If we are having an online course, this is not applicable. So there are also information about the Math Learning Center, this at MPC, and also they have online tutoring. So check their website to get information. Then we have the course calendar. So you're gonna see that every week we're gonna cover 2 chapters most of the time, and we're gonna have our test. So everything is here. Check the syllabus, and with that we're gonna be able to continue working during the semester. So the main points from the syllabus are the contents of what I'm going to teach you. That is in the course description. What you are expected to learn, that's on student learning outcome section. How are we both going to accomplish our goals, that's course policy. And the way that we're going to do it is through classwork, quizzes, homework, tests, and a final exam. So again, you have here the grade distribution. So work well, everything according to the calendar, and you're gonna pass this class. As you can see, 50% of the grade is only your work at home. You watching the lectures, solving the quizzes online, and the other 50% is just tests and the final exam. So it's not a lot work to do to pass this class. So the way that I used to teach this class is I'm going to provide you with concepts, which are just terminology, new terminology that you might need to learn the meaning, and also procedures, so recipes to do many things. So we have again classwork, which is uh, watching the lecture, attending the lecture, and solving the problems that are going to be assigned during the lecture, and also homework, which is another set of problems very similar to the ones that we solve in every lecture. So I'm going to explain, we're going to practice, you're going to apply. So work on the classwork problems, solve your quizzes online. That's a very important thing. Remember, the quizzes is just for you an idea. It's going to give you an idea on the kind of problems that you're going to have in the test and in the final exam. So you know a little bit about me. Now I would like to know about you. So you're gonna get a piece of paper. You're gonna write these questions and you're gonna write the answers. Take your time. At the end, you're gonna take some screenshots and you're gonna use your app for the first time to convert screenshots into a PDF file. You're gonna have plenty of time to do these assignments. Usually, I am going to give you 1 week to work on your classwork, to work on your homework, and to work on your quizzes online. So please respond to these questions. So now that you know a little bit about me, you can see that the only problem that you might have in this class, I'm going to tell you this up front, is my accent. So I'm going to try to speak as clearly as possible. And also I'm going to take notes and I'm going to post those notes online. Uh, And the important thing is I'm going to do my best for you to understand statistics. Statistics is a science that is sometimes is confusing. So I'm going to try to look for the best way for you to understand in a very simple manner how to deal with the problems on statistics. So we're going to use this book. Is the book that all the instructors teaching statistics at MPC are using. So this book is Elementary Statistics, is the 3rd edition, and is by William Navidi and Barry Monk. So I'm going to be showing most of the time sections from the book for you to be on the same page. And also, as I mentioned before, I'm going to be taking some notes. So we're going to start now with chapter 1, section 1. And this chapter is just about basic ideas on a statistic. So I read this chapter many times. I read a lot of books on statistics. I'm trying to get the simplest way to say what statistic is. So in statistics, what we do is that we deal with data. So we're gonna have data, and that data usually comes from a source. Uh, that source, the source of our information, the source of information is gonna be a population. a population. So a population is going to be just a collection of items. So it can be anything. It can be just scores, SAT scores or GRE scores, or it can be heights of people, or it can be income, or it can be just your favorite sport team. There are many populations that we can create or we can envision. And the important thing is that sometimes you're going to be able to get all the information, all the population values as your data. So if you use all, this is equivalent to working on a census. Or you can just get part, a fraction of the population items. So if you are working just a part, this is going to be a sample. So we're going to get data. And with that data, what we want to know is we want to learn. So statistics is about learning. It's about learning about the population. So we want to know about the population. We want to know features of that population. Sometimes we have just a little portion of the population, and with that little portion, we're going to be able to get some features of that population. So that is going to be the main part of this course. So also, once you learn about the population, you can also make decisions. So we're gonna make decisions related to that population, but only based on the data that we collected, the data that we were able to obtain from the source. So now, if you check the book, if you check any course of statistics, you're going to see that the recipes, the procedures are going to be the same. So you have your data and you go through a procedure and you follow the procedure and you're going to get to a point, and most of the time it's going to be always the same point. You're going to need to work with a graph, of a statistical model. We're going to learn about this later. This is just the big picture of this course. So you're going to have a graph that you're going to use to make a decision. So, and what you need from this graph is not the equation describing the graph. So there might be an equation describing the graph. So we don't need to know this. We don't need to know this. So we don't need fancy math. We don't need advanced math to know the equation that describes this curve. What we need to know is only the area that is under this curve between values, between boundaries. We're going to set these boundaries. We're going to find these boundaries, but the most important thing is that we need to know this area. So if you understand this, if you understand that most of the time we're going to be working on areas under a curve, you're going to see that this is very easy. The area is going to be related to a concept that we know as probability. But we need the area. We need the area under the curve between boundaries. Now, how are we going to get this area? That's when there are different types of courses. So we're going to use either tables, and your book has tables. So we're going to have tables where you're going to be able to provide the boundaries and then you get the area. Or you provide the area and you get the boundaries. So there are tables in your book. In the past, many instructors use the calculator Texas Instrument 8384. So you needed to know commands and to work with menus. So it was a little confusing because the students needed to remember a lot of steps just to use the calculator to get the area. So to get a simple value, you needed to do a lot of work. So now we're gonna use another tool, a powerful tool. We're gonna use Language R. So Language R is free software available worldwide. Is the software that most of the statisticians and mathematicians use, use, and it's something that you might need in your career later or in your work if you get a job with the government or a company. Knowing language art is going to be very, very appreciated. So you're going to learn a little bit about language art. I'm not going to teach you how to program in R, so we're not going to use language art as a programming language. We're going to use language art just as another calculator, but very powerful in the sense that you're not going to need to work with a lot of menus. You're just going to type the kind of information that you want, and R is going to give you that information immediately. So I'm going to show you now how to get R, because that's what you need. So this first lecture is going to be about installing R into your computer, and also doing a very simple exercise that is going to show me that you were successful in installing R and playing with R during this very first day. So I'm going to show you now how to install R. To install language R, you're gonna go to Google. If you have a Macintosh or if you have a Windows-based machine, it's gonna be the same procedures. So you're gonna type cran R, cran and space R, and then you're gonna get a page like this one. So here you're gonna see that there are a link for Windows, and also there should be another link for Macintosh. Let's see, for Windows, and for Macintosh. So you have here the link for Macintosh. So don't install R Studio, so you don't need that. We're gonna need the R console, as I mentioned before. We are not doing R programming. We are only using R as a calculator. So if you go here, you're gonna get to download a file that is gonna give you access to install R into your computer. So also, if you go to this page, I'm going to write the page on the notes. It's just cran dot R hyphen project dot org. So it's going to be a free software. So you're going to have here the link for Macintosh, the link for Windows. There is another link also for Linux that is used when you have a Chromebook. I don't recommend you to install R in a Chromebook because it's a little bit complicated. You're going to need to know more about how to use computers. If you know how to do it, do it. If not, then you're going to have the opportunity to use a different way to deal with R. So once you install R in your computer, you're going to be able to see, let me see, I'm going to show you my computer now in a minute. So once you download and install R, you're going to see icons on your desktop. So you're going to look for this icon and double click, and then you're going to get access to the R console. So we have in our note now how to install R. So remember, you can Google cran R and find links to have the corresponding files to download if you are working with a Windows machine or Macintosh. Or there is another way to work on R. So this is a very important way to work on R if you don't have a Macintosh or you don't have a Windows machine. So for example, if you have a Chromebook, an iPad, iPhone, or your Android smartphone, you can use R online. So there is a link in Canvas. I just posted a link in Canvas, or the same link can be also obtained if you go to about.me/arreguin. you're gonna find the same links. So let me show you the link that is in Canvas. So let's go to Canvas. So this is our main page. So you can go here and you're gonna have this link here, R online compiler. So if you click here, you're gonna get into this page. The full link is here, but it's sometimes you can just make a typo and then you don't get the link. So it's better if you use the bottom that is in Canvas, or go to about.me/Arreguin. Arreguin, you're gonna get the same page. So this web page is containing compilers for different programming language. For example, Python, as you can see here. So if you go and check, you scroll down, you're gonna see that you're gonna find this section that says how it works. So this section, how it works, is about language R. So there are two windows here. You can see on the left part script. They are showing you how to use R as a calculator, and on the right hand side you have an R console. So check here, an R console. So, and you have here the opportunity to type anything. So this is the section that you're looking for if you are using R online. And if you are using your smartphone, it is likely that these two windows are not going to be one after the other. In this way, horizontally, they are going to be one after the other vertically. So once you find how it works, continue scrolling down in your smartphone and you're going to find R console. That's what you need to get to be able to enter information into R. So now I'm going to give you the assignment, the first assignment, important assignment about R. Once you install R, then you're gonna run a very, very short pair of commands to test the system. So we're gonna test your installation. So this is gonna be testing R in your computer. So you're gonna just do a very simple thing. You're gonna type something like x equals, then you're gonna type R N O R M, so R norm, a parenthesis, then 1000, you close that parenthesis, then you press enter, and then you're gonna have another command, and it's gonna be hist, H-I-S-T, parenthesis, and then again the X that you enter here is gonna be the same one that is gonna be here. So we're gonna use lowercase for everything. So this is your assignment. You're gonna enter these two lines of information into your R console. In your R console, either by using the online version or using your new install version, and this is what you're gonna see. So let me show you. So you have your R console. So this is the page that you're gonna see when you use your R in your computer. It's slightly different from the other one that you have when you use the online version. In the online version, you only see this little part here, the cursor and the prompt. So that's the only thing that you see when you use the online versions. All these messages, all this information is not in the online version. So, and you're gonna see all the time these messages. It's just copyright messages, a copyright message. So let's type what I just mentioned before. You're gonna type x equals R norm, and then parentheses, and then 1000, then you close the parentheses, you press enter, and then you're gonna type hist x, and you're gonna get a plot. You're gonna get this beautiful graph. So you're gonna take a screenshot of these results. And with that screenshot is going to be converted into a PDF file by using the apps that I mentioned before. I'm going to write the names again in our notes. So, and this is going to be your first assignment. So in classwork 1A, you need to upload this screenshot, the screenshot of this page. It's going to be the same result if you use the R console in your computer or if you use the online version of R. So let's just finish this part of the our close work. So you're gonna take a screenshot, then take a screenshot of the uh, display, of the computer display, and then you're gonna use something like, for example, cam scanner or PDF scanner. So there are many apps. The purpose is to get a PDF file to upload into Canvas. So you're gonna look for classwork 1A and look for the submit button, and that's what you're gonna send me. That's what you're gonna send, and that's gonna be your first assignment for this class. And this is important because when I check this, I'm going to know that you were successfully installed, that you successfully installed R into your computer, or that you were able to use the online version to do computation. And this is going to be our tool. No needed. You don't need to buy a Texas Instrument, a very expensive computer, or to buy software. So this is free, and this is going to be good for you. So now we're going to start our first section. So our first section is going to be on page 2. So we have section 1.1. So you're going to see a lot of definitions because this chapter is about definitions. So we're going to have definitions that we need to learn. So for example, the most important one is the definition of statistics. So it's the study of procedures for collecting, describing, and drawing conclusions from information. And then we're going to use these two words a lot of times during this course. We're going to use the word population and the word sample, and they are related to each other. So a population is the entire collection of individuals about which information is sought, and a sample is a subset of that population. So that's one of the definitions. There are going to be more definitions that you're going to find in the following pages. I'm going to go through only the most important ones. If you need to know more about this, you need to read the remaining definitions, because maybe in the quiz you're going to need to respond questions about other definitions, but they are going to be very simple questions. So the other definition is a simple random sample of size n is a sample chosen by a method in which each collection of n population items is equally likely to make up the sample. For example, like playing the lottery. So I've just wrote here those definitions for your notes. So section 1.1 is about sampling, and the definitions that we need to not memorize, because you're going to be able to understand this without memorizing. So it's statistics, population, a sample, and a simple random sample. So you can say that if you have a population, if this is your population, and you get a little portion, or you get a little few elements from here, the way that you collect these elements is what distinguishes every sample. So you collect these, and you get your sample with a subset of elements of individuals from the population. So when you use the entire population for your to get statistics, to work statistics, then you call the entire population and the entire procedure a census. But if you only collect a portion of the elements, that's a sample. So uh, you're gonna need to read very carefully the problem. So the crucial part to solve a problem is you need to read carefully the word problem, because sometimes they're gonna tell you explicitly this is a population. Sometimes they're gonna tell you this is a sample. So read carefully, and with that you're gonna be able to solve a lot of problems. So sometimes just by reading you get a lot of information. So this is gonna be okay. Let's go on the next thing. So we have now that sampling is important. So collecting samples. There are many ways to collect samples. So one way is just to get a simple random sample that we've whose definition we found on page 3. And there is another way to collect samples, and that's when you get a sample of convenience. Sample of convenience, that the sample is defined on page 5. In few words, is when you get a sample in the best interest of the person doing the sampling. So for example, you want to know about income in a city, and you decide to conduct a survey. And survey is just you're gonna ask questions to people about their income, and instead of looking a random way to get the sample, like for example using a random number generator, you just go to with your neighbors and ask your neighbors. That's a sample of convenience, because you go and ask questions to your neighbors because they live near you, and you're gonna save time and you're gonna save uh, resources. But that sample is not going to represent the city that you were trying to know of. So, but that happens. So there are many ways to get samples. So you're going to learn about those ways in this chapter. Later in the course, you are going to be given the sample. So you don't know, or you are not interested in the way that they got the sample. As long as they say that it was a simple random sample, you're not going to look for more information about sampling. So let's start solving examples. So I'm going to start solving example. Let's see. We're going to start with example, I think example 1 is going to be the first one that we're going to work on. Example 1.1. This is on page 3. So let's read that example. So the example says that there are 300 employees in a certain company. So the human resources department wants to draw a simple random sample of 20 employees to fill out a questionnaire about their attitudes toward their jobs. Describe how technology can be used to draw this sample. So the way that we're gonna get the simple random sample is you have the list of 300 employees, and you're gonna assign a number to every employee. So you're gonna have numbers from 1 to 300. Then you need a tool to pick numbers randomly, to pick 20 numbers, because you need 20 employees to fill out the survey. So you need 20 numbers, but those numbers should be obtained randomly. So the way that you're going to do that is you're going to use a random number generator on a computer or a calculator to generate 20 random numbers between 1 and 300. So we're going to use R. So this is going to be the first application. We're going to use R to do sampling to obtain a simple random sample for this problem. So we have example 1.1 on page 3, and we have 300 employees. So we have numbers. I'm going to say that I have numbers from 1 through 300. There are two ways to enter this information. The most common way is when you enumerate the individuals in your variable. In this case, my variable is going to be used to identify the entire population, because my population is 300 employees. So X in this case is going to be the 300 numbers. So it's going to be numbers from 1 through 300. So one way is you use the lowercase c to indicate a collection, parentheses, and you enumerate all those numbers. So you start 1, 2, 3, 4, until you get 300. But this is very painful. So there is a shortcut to do this. So instead of doing this, because this is a time-consuming way to enter a population, you're going to just identify the minimum value 1, then you use colon, and then you indicate the maximum value 300. So in this way you are telling R that you have a collection of numbers going from 1 through 300. So 1, 2, 3, 4, and so on. So that's my population. That's the population. That's the population. Now we're going to generate the sample. So to generate a sample, we're going to use the command sample. So you're going to see that R is very, very simple, because you're going to use many times the same words that you use in your book. So you're going to use the word sample, lowercase for all commands in R, lowercase for all commands in R. Don't forget that. So we're going to use sample, then we're going to use a parenthesis, and then we're going to write X, because we are drawing the sample from X, and we want only 20 values. So this is the size of the sample, and this is going to give me a simple random sample. So with this command sample X, 20, and then you're going to be able to see 20 values, and then you check the list with the names of the employees and check the corresponding numbers, and then you're going to call those employees and say, hey, you need to fill out this survey. So let's use R. You're going to see R, and you can play with this exercise many times, and you're going to see that anytime that you call sample X20, you're going to get a different set of numbers, not always the same set. What is more important, you're going to get a different set of numbers than the ones I'm going to obtain in these lectures. And don't worry, that's the purpose of a simple random sample. So let's go and check on R how to do this. So you're going to see that this is not complicated. So I have here the previous exercise. So you can just go directly and click here. So the graph is still there. If you want to check the graph again, you just go to Windows and look for graphic device, and you get the graph back, but we don't need the graph now. So I'm going to reassign X. Now X is going to be a different thing. So X is going to be just values between 1 and 300 by using the colon symbol. So now X is different than before. So now X is no longer 1000 values that I collected here. So I'm going to sample. I'm going to sample from X 20 values. So you're going to see here 20 values between 1 and 300. So you have 18 values here on the first row and 2 more values on the second row. So you're going to go and check, for example, what employee has the number 101, and you're going to ask her or his the questions and so on. So you're going to give the questionnaire to every person that has this number. So if I repeat, and you can repeat any command by using the up arrow in your keyboard. If you look for the up arrow, it's going to give you the previous command, the one that you used before. If you press again the up arrow, you're going to get the command that was before that, the previous one, and so on. If you use again the up arrow, you get all the previous commands. So let's go and just use the up arrow one, and then I'm just going to type enter or press enter. I'm going to get a new set of 20 values that are randomly chosen from the population. So my sample now of 20 values is different from the previous one. And also remember, if you do this in your computer, you're gonna get different values than the ones I am obtaining, because that's a simple random sample. So that's exercise or example 1.1. So let's go back and continue doing another exercise, and then you're gonna have time to work on this by yourself. So now we're gonna work another exercise. So we're gonna work exercise 1.5. So let's write here example 1.5 on page 4. So now let's see the problem. We have the problem here. So let me show you the problem. So we have this thing. When I use an example 1.5, I'm going to use technology to draw a simple random sample. So use technology to draw a simple random sample of 5 employees from the following list. So I have now 40 employees. You can see from 1 to 40, we have the names of employees from one company. Now we need a simple random sample of 5 employees only. So your book shows you how to use the text as instrument to get that sample. We're going to use R. So what is the command that we are going to use? The command that we are going to use is the following. So we have now, and we can use again X, or you can use another variable. You can use Y or Z, but let's use X. X is going to be now values from 1 through 40. So that's my population. That's the population of employees. Now I need 5 employees. So now I need the sample size is 5. So I need 5 employees. What is the best way to do this? We're going to use again sample. We're going to sample from X. Now we're going to sample only 5 values. So that's what we're going to do now. So let's see. Let's go back to R. So, and let's do the exercise. So I'm going to write now X equals 1 through 40. So you don't see the 40 values because I haven't called X. If you want to see the 40 values, you just type X and you're going to get the 40 values, 1 through 40. But we don't do that because usually our populations are very big. So we know that the values are inside of X, or they are stored in X. We don't call them. We don't need to see them. Okay, I need a sample from X with only 5 values. So it's going to be 23, 1, 25, 12, and 38. So then you go and check the list. So, and you're going to check the names. So you're going to see that 23 is Jared Kearns. Number 1 is Dan Aaron. Number 25 is Frank Lipka. Number 12 is Carlos Garcia. And 38 is Jermaine Tryon. So what I'm doing this, because usually you are the statistician, you are asked to solve a problem, but you don't need to provide the numbers to human resources department. They want the names of the people that you want to suggest that they should interview. So you are not going to say, oh, here you have 5 numbers, 23, 1, 25, 12, 30. No, you can say, uh, please, this is the list. So you're gonna need Dan Aaron, you're gonna need Jared Kearns, and so on. Okay. So many times we're gonna provide our answers in a way that is understandable for any people, even if they don't know anything about statistics. So okay, that's example 1.5. So now let's see what is the next problem that we're gonna solve. So we need to work now another example. So we're going to talk now about the different kinds of another kinds of sampling. So let me just go back to our notes. Okay. So we finished this problem. So now let's start the next part. So we're going to learn now about another ways to do sampling. So we have stratified sampling. Stratified sampling. This is defined on page 6. So let's see page 6. Okay, on page 5 you have the definition of a sample of convenience. It's a sample that is not drawn by a well-defined random method. And then on page 6 you're going to have the definition of systematic sampling, and the definition of cluster sampling, and the definition of stratified sampling. So I'm just going to read you the definitions, and then we're going to solve a problem. So in stratified sampling, the population is divided into groups called strata, where the members of each stratum are similar in some way. Then a simple random sample is drawn from each stratum. Stratified sampling is useful when the strata differ from one another, but the individuals within a stratum tend to be alike. So for this kind of sampling, this is what you're gonna do. So you have, for example, a population, and you're gonna have subgroups. So you're gonna have subgroups, and let's say that you have groups A, B, C, and so on. Then you're gonna get samples from each group. So you're gonna sample from A, you're gonna sample from B, and so on. You're gonna sample from C, and then you're gonna collect everything, and this is gonna be your stratified sampling or stratified sample. So you're gonna get your sample, collecting all these samples. So for example, you might have a population of you can say, for example, men and women, and more categories if you want. And then you collect a sample from here, you collect a sample from here, and then you join the samples, and then you get your sample. Okay. Now another kind of sampling is cluster sampling. Cluster sampling is defined also on page 6. So now you have your population, and again you have subgroups. So it's very similar to the previous one. The difference is in the way that you're gonna collect the sample. So you're gonna have your groups, but now instead of sampling from each group, each subgroup, you're gonna get a sample of subgroups. So this is important. You're gonna get a sample of subgroups. How do you do that? If you have 4 subgroups, then you're gonna sample from 1 through 4. How many? Depending on how many subgroups you want in your sample. So you get a sample of subgroups and collect all the individuals from those selected subgroups. So you collect all the individuals from the selected subgroups. This is very important. Sometimes students tend to be confused about this. Stratified sampling. So you're gonna sample every subgroup. Every subgroup you're gonna get individuals for every one. So if you have 4 groups, you're gonna sample 4 times. In this case, if you have 4 groups and you are only collecting information from 2 groups, you're gonna sample the number of the group, and then the number is gonna tell you what group is gonna provide all its elements for the sample. So let's see. You might have a population like this one. So you have subgroups, and those subgroups are going to be the following. So you have a lot of people here in every group, but you're going to label each group. You're going to label each group. And then you're going to say, for example, n, the number of the group, is going to be a collection of 9 values. So you can enter, as I mentioned before, any value individually. You can do that when the values are not many, or when they are not following a simple pattern. So I'm entering the 9 values in this way, or you can enter the values, remember, 1 through 9. And then you're going to sample. If you only need 2 groups, you're going to sample n, and you're going to get 2 values. And then those values are going to be the ones that you're going to collect all the individuals from those 2 subgroups. So for example, if you get numbers 3 and 5, then you get all the individuals from 3, all the individuals from 5, and you conduct your survey with that. If you were conducting a stratified sampling, then you're going to apply sample for every group. So that's what you're going to do. So I'm going to assign you now, this is the last part of this classwork, 1A. And if you have questions on how to solve these 4 problems, then you just send me an email and I can help you. So you're gonna work on the exercise set 1.1 from your book. This exercise set is on page 10. So you're gonna solve these 4 problems: 21, 22, 23, and 24. So it's just about sampling. So you're gonna use the command sample to solve this problem. So let me show you just the problems. This is on page 10. So let me see. We have page 10 here. So we need 21, 22, 23, and 24. So I'm going to show you first 21 if you don't have your book yet. So, and you can see here. So those 4 problems, 21 through 24, are based on this table. So exercises 21 through 24 refer to the population of animals in the following table. So you have here the table. So the population is divided into 4 groups: mammals, birds, reptiles, and fish. And you have all the species and all the individuals from each group number. And then problem 21, you're just going to get a simple random sample. So draw a simple random sample of 8 animals from the list of 40 animals. So first, you're going to work with the list as a single group, and you're just going to get 8 animals from that list. Then, and this is a simple random sample. Then the next thing is, like, now you're gonna get another sample. You're gonna draw a sample of 8 animals by drawing a simple random sample of 2 animals for each group. So now you're gonna get 2 animals from here. So you need to get a number. You need to get 2 numbers between 1 and 10. Then 2 animals from here. So you need to get 2 numbers from 11 through 20. Then another 2 animals from this group, so you need to sample from 21 through 30, 2 numbers, and finally from 31 through 40, another 2 numbers. So that's problem 22. Now 23, you're going to draw a simple random sample of 2 groups of animals from the 4 groups and construct a sample of 20 animals by including all the animals in the sample group. So now you're gonna have group 1, group 2, group 3, group 4. So sample from those 4 numbers, and the numbers that you get, the 2 numbers that you get, are gonna be the ones corresponding to the groups that you're gonna get all the elements for your sample. And they are asking you, what kind of sample is this? And finally, another sample. Choose a random number between 1 and 5. Include the animal with that number in your table, with that number in your sample, along with every 5th animal thereafter to construct a sample of 8 animals. And the question is, what kind of sample is this? So that's that's the lecture for today. So we're going to continue the next time for the second part of this chapter 1.